Something is stalking the night sky. At least, that's what the rumors say. People claim a black hole is hiding behind Mars, and that James Webb saw it. If that were true, our planets, our tides, even our light would be in danger. Tonight, we test the claim with real space facts and clear proof. Did Webb actually find a black hole near Mars, or is this the scariest space hoax yet? The rumor starts as a whisper on a late-night screen. A post says there is a black hole hiding behind Mars, waiting in the dark. The words feel heavy like a door slowly closing. You picture the red planet, dusty and small, sliding across a silent sky. You imagine a hole so strong that light cannot escape, pulling space like a tight rope. The post shows a blurry picture and a bold claim. It says a giant thing is close, closer than we think. Your heart counts beats. 1, 2, 3. You try to measure the danger in your mind like lining up rulers on the floor. Mars feels near tonight, even though space is wide. You read numbers in the comments, big ones like 1,100,000 kilometers, like 228,000 kilometers. Some say run, some say pray, some say the new space telescope saw it and stayed quiet. You lean in until the screen light warms your face. Your breath makes a small cloud on the glass. The room smells like dust and paper. The clock ticks, steady as a metronome, and the glow paints a thin line on your desk. You want truth, not fear. You press pause on the video and listen, the way you listen before a storm. The house holds its breath. If there is a monster out there, it will twist orbits and bend light and shout without sound. If there is not, the lie is the scary part. Tonight, we start finding out slowly. You meet the real star of our story now. James Webb is not a spaceship that flies around. It is a giant eye that stays far from Earth, about 1.5 million kilometers away at a place called L2. Its gold mirror is huge, about 6.5 meters wide, with 18 shiny pieces that fit like a honeycomb. A silver sun shield the size of a tennis court blocks heat and light. 5 thin layers keep the telescope cold, near 40 Kelvin, so it can see faint heat from space. Webb looks in infrared, light our eyes cannot see, from about half a micron to 28 microns. It studies baby stars, planets, and old galaxies. The craft does not spin or chase planets. It faces away from the sun and keeps a safe angle from Earth and the moon so the shield stays cool. From L2 it makes gentle loops, like a slow halo. Ground teams send tiny nudges to keep its path steady. Every move is careful, because the mirror must stay still by about a human hair. Sensors read heat, light, and tiny shakes. Numbers stream home by radio, crossing space in 5 seconds. Webb cannot peek behind Mars like a kid hiding in a game. It sees wide sky, not secret corners, and it is built to study the far, not the near. Still, its sharp sight finds surprises. If a monster truly lurked close by, its pull would twist paths. Tonight we keep that test in mind for us. You cannot see a black hole, but you can feel its pull by what it does to nearby things. A black hole is space squeezed so tight that nothing can get out, not even light that moves 300,000 kilometers each second. The edge is called the event horizon, a one-way line. Cross it, and you do not come back. Small black holes can be the size of a city, with a horizon about 30 kilometers wide for 10 suns of mass. Giant ones live in the centers of galaxies. Ours is named Sagittarius A's, about 26,000 light-years away, and 4 million times the mass of our sun. Its horizon is 12 million kilometers across, yet from here, it looks quiet. Black holes do not suck like a vacuum. They pull like any heavy thing. If the sun turned into a black hole of the same mass, Earth would still circle at 1 year, darker and cold. What makes them glow is the hot disk of gas around them. Falling gas gets squeezed and heated to millions of degrees. It shines in X-rays and in infrared, and jets can fire from the poles. Stars near a black hole move fast, like sparks. We time those orbits with care to weigh the beast. These facts draw a clear rule we will use later. If a black hole were hiding close by, it would change paths, bend light, and shout in heat. The sky would notice, and so would we. Mars is not a secret place in the sky. We watch it every day with radio pings and lasers. Spacecraft circle it, land on it, and drive across its dust. Its path around the sun is measured so well that tiny changes show up, even shifts smaller than a house. If a heavy black hole sat behind Mars, its gravity would tug the planet, twist the moon's Phobos and Deimos, and nudge our probes off course. The math does not show that. The orbits stay smooth like tracks on clean ice. Light from stars that pass near Mars does not bend in strange ways. No sudden flares, no hot disks, no jets. A small, ancient, primordial black hole could be tiny. But if it were close, it would still shake something we watch. We see nothing like that. Mars ranges from about 55 million to more than 400 million kilometers from Earth during its loop. We can time radio signals to a split second. A hidden beast would make those times drift in a clear pattern. Data stays steady. You can hold a ruler to it day after day. Webb does not chase Mars. It stares deep and cold, hunting faint heat far away. That is where the monsters live. In the early universe, bright as quasars. So the scary claim fades under simple checks. Still, keep the rule we set. If gravity is there, it leaves marks. We will keep looking for marks as the story moves on. Webb hunts the faintest heat like a campfire ember seen from across an ocean. Its cameras sip light in the infrared from 0.6 to 28 microns, colors our eyes cannot see but our skin can feel. NIRCam makes sharp pictures. NIRSpec splits light to read thin lines. MIRI tastes cooler glow from dust and gas. The gold mirror is 6.5 meters wide, so small dots become clear shapes, and smudges turn into baby galaxies. Red light stretched by the expanding universe tells age and distance. A tiny bend in a line can reveal carbon, oxygen, or water vapor hiding in the dark. Sometimes gravity helps too. A huge cluster acts like a lens and boosts faint light. It studies stars being born inside dusty clouds, hot disks around black holes, and the first galaxies that lit up the night. Numbers guide every step. Exposures last hours. Temperatures stay near 40 Kelvin. Pointing holds steady within fractions of a human hair. From L2, signals take about 5 seconds to reach Earth, where teams check focus, drift, and noise. This work is slow and patient, very careful and calm. Yet the pictures feel shocking. Spiral arms, needle-thin jets, arcs of lensed light. These are the places where real monsters feed, billions of light years away. If a nearby black hole lurked close to Mars, Webb would not need to see it directly. Other tools would reveal its pull. Webb's gift is distance, heat, and time, and that is where our search now leads. Far from our calm night, real monsters roar. They are quasars, where giant black holes eat gas fast and glow brighter than 1 trillion suns. Webb sees their warm dust and sharp lines in the infrared, the colors that carry through thick space fog. Around the hole, a hot disk spins at near light speed, grinding gas into light. Some quasars shoot narrow jets that stretch for thousands of light years, thin, very thin spears that stab the dark. Their light left when the universe was young, more than 12 billion years ago, and only reaches us now. Webb measures tiny wiggles in that light to tell how fast the gas swirls and how heavy the black hole is, sometimes 1 billion times the mass of our sun. The numbers look scary, but the truth is calm. Those engines live far away. They cannot touch Mars or Earth. If they were close, the sky would tear with X-rays. Stars would speed like sparks, and orbits would twist out of place. We see none of that here. What we do see are clues to how the first cities of stars formed, how dust cooled, and how gravity built the big things. The horror is not danger, but power. Matter falling, heat rising, time stretching, light bent into arcs. Webb turns fear into facts by making careful maps of that power. Keep that in mind as we turn back toward home. If a threat were near, the same signs would shout at us. Webb brings a new shock from the deep past. In its faint red light, we find baby galaxies that already host big black holes, far sooner than most plans allowed. The clocks say the universe was only a few 100 million years old, not even 1 billion yet, when some of these engines were already heavy. Their mass looks like many millions of suns, sometimes more, packed into a tiny, hot center. The lines in their light are broad, like thick brush strokes, which means gas is whipping around fast. Dust glows warm, close to body heat in numbers, and the spectra show it clearly. This speed and heat tell a story of rush and growth, not a slow climb. How did they grow so much so quickly? Did they start from giant seed stars that crashed and made heavy cores? Did clouds fall straight in and skip the star step? Webb does not shout the answer, but it points a bright finger at the puzzle. The surprise is not a scare for us at home, but it bends old charts. We must redraw how the first lights turned on, how gas cooled, and how gravity stacked the early sky. The tension lives in the numbers. Ages under 1 billion years, masses in the millions of suns, distances of billions of light years, and lines spread by thousands of kilometers per second. Each new picture is both a gift and a dare. Keep looking, it says. The rules might be different out there. We test wild space claims with careful light. First, we split light like rain through glass and read the thin lines inside. Each line sits at a known place, like a note on a piano. If the gas is moving fast, the line grows wide. If the galaxy is far, the line slides red. Webb's tools do this work in heat light from 0.6 to 28 microns, where dust is bright and young stars hide. NARSpec pulls the lines apart. NARCam marks the sharp shapes. MIRI checks cooler glow. From these pieces we read speed, mass, and mix, the way a doctor reads a heartbeat. Broad lines mean gas whipping by at thousands of kilometers per second. A deep redshift means the light left billions of years ago. Extra glow from warm dust points to a hungry core. We also watch how light bends near heavy things. A small arc can say, there is great mass here. Then we ask a hard question. Do we see these marks near Mars? The answer stays quiet. No wide lines, no hot disks, no bent paths. The tension remains, but the method is sound. Now we are ready to test the last claim. We turn the lens back home and make the simplest checks first. Mars moves on a clean track, year after year, like a bead on a wire. Spacecraft around it send radio ticks that reach Earth in tight rhythm. If a heavy neighbor tugged at Mars, those ticks would drift in a steady pattern. They do not. Phobos and Deimos keep their small dances with only tiny, known changes. Starlight near Mars does not bend in strange arcs. No hot disk flares on the planet's edge. No X-ray shout, no jet. We time signals to split seconds and measure distance to meters. The math is calm. The numbers agree. If a small ancient black hole were close, it would still nibble at orbits, heat dust, or seed brief flashes. We do not see that, not in radar, not in images, not in spectra. Webb was built for the deep and the dim, not for peeking behind a single world. And still the sky would tell on any monster nearby. It has not. The rumor sounds large, but the universe leaves marks when it moves great weight. Tonight those marks are missing. That silence is our answer, and the fear begins to fade. Here's the truth we earned tonight. James Webb did not find a black hole hiding behind Mars, and sky near Mars stays calm. Numbers hold steady, paths are smooth, and signals come back on time. No bent starlight, no hot disk, no jet. The scary part was not a secret beast next door, it was a rumor that grew in the dark. But the real story is better. Webb's cold eye at L2 reads faint heat from bright cities of stars, where giant black holes woke early and fed fast. Those engines live billions of light years away, and their light is old, stretched like a long red ribbon. We can measure their mass, their speed, and their dust, and learn how the young universe built itself. This is fear that turns into wonder, the kind that makes you lean closer and listen as data speaks. Back near home, simple checks win. Mars moves like a bead on a wire, steady and sure. Probes count seconds, moons keep time, and math agrees. If a monster were near, gravity would leave marks. We would see crooked orbits, hot flares, or sudden bends in light. We do not. So we close the tab that shouted doom and keep tools that gave us peace. Use care. Ask for evidence. Trust the quiet power of measured light. Let wild claims fade while the real universe opens. Come with us as Webb looks deeper, where old shadows burn and the first monsters sing in light.